Hi, we're this traffic simulator group, and this is our presentation for our what we did over this summer. So, my name is Sheza Bajwa, and this summer I worked with Afreen, Sebastian, Mohammed, and Anna to create this project. So, our project was to develop a smart city intersection for the model intersection in the Orbit Lab. And there we have a model replica of the intersections of 120th and Amsterdam Avenue and 120th and Broadway in New York. To create a realistic simulation, we used three main programs. First of which was Sumo, or the simulation of urban mobility, which was used to create our traffic models. Secondly, we used Gazebo, or robotic simulator, to build the entire world around, which shows the roads and cars. And we wanted to connect this world to Sumo so we could have traffic models built in Sumo be seen in Gazebo. So we used ROS to communicate between Sumo and Gazebo.
So for our project goals and relevance, we basically wanted to feed real-time data from Sumo to Gazebo to create a virtual model of traffic in a dense city. And basically the Gazebo software provided a 3D robotic simulation of the data collected from Sumo. We also wanted to create objects within the simulation, such as a traffic light, and this would add like a realism factor. Adding a traffic light would basically help accurately emulate a real city intersection. So the intersection model and explanation. The intersection model was designed from input data from technologies employed such as Sumo and Gazebo, as mentioned earlier. And how this basically works is that, just to reiterate, we know that Gazebo reads the information given by Sumo, such as 3D coordinates for street intersections, cars, pedestrians, traffic lights, um, and more information on these specific objects is yet to come. But it should also be noted that these plugin values cannot be executed as commands in the simulation. This must be done in the simulation itself. And we can delve deeper into this on the next slide. So this is a video of how the simulation runs. On the left-hand side, you could see our Sumo software. And on the right-hand side, we can see our Gazebo software. And it should be noted that the entire simulation is done in real time. And you can also see RVIZ being employed, which is basically another 3D visualization tool that we utilized for our hybrid simulation. And the purpose of this tool was basically to provide us with camera data about the movement of simulated cars. And we were able to use this as even more input data. So I'll let the simulation run. And we can see that both simulated cars in the Sumo software and the Gazebo software have very similar movement, and this is largely due to the RVIZ application that we used. And now I'll give the floor to my colleague Afreen, who will go more in depth on one of our simulated objects.
So we were also tasked to create a stoplight that can take commands from a publisher node, and here's a video demonstration of that. To create this stoplight, we had to draw a model, again, create a publisher node, a Gazebo plugin, and ROS topics. A node is an executable that uses ROS to communicate with other nodes. So in a moment, you will see that we're able to control the lights. And after it launches, 1 for red, 2 for yellow, 3 for green. We hope that this can be applied within our hybrid simulation to control traffic more accurately. As you saw, the publisher node took keyboard commands, and the plugin allowed us to see the lights change in Gazebo. Topics bridge the gap between both the publisher node and the plugin. The overall purpose of making this was to show that we can add more variables within the simulation, such as people, and we would be able to feed the simulation more accurate data about the intersection. Thank you. Any questions?